Okay, just a quick review on multiplication. So, on number 1, we just have a straight distribution problem. So you're going to send the 4 in and the 2 in, but remember, send it into both. Okay? Actually, wait a minute. I just realized there's no variable here. So on number 1, actually this is simpler. Just make this 11. Simplify inside first. Okay? It would still work. You get 28 plus 16, but why not just make it 44? Over here, we are going to send the 2 in and make 2x plus 12. Biggest problem you'll make, still in every math class, is not sending the 2 to the 6. So subtract 12, and you're going to get 32 equals 2x. X equals 16. Now number 2, remember this is FOILing or distributing or multiplying, however you want to call it. So FOIL means first times first, x times x, outer, outer, 5x, inner, inner, 2x, last, last, 10. So again, that's x squared plus 5x plus 2x plus 10 equals, remember to send this to both sides, 2x squared plus 4x. So we're going to simplify the left side. X squared plus 7x plus 10 equals 2x squared plus 4x. Now we need to get everything on the same side. So actually I'm going to move everything to the right to keep my x squared positive. So I'm going to subtract x squared, which gives me x squared. I'm going to subtract 7x. And I'm going to subtract 10. And now, we need a factor. So remember factoring. We need two numbers that multiply to give me 10 that differ by 3. So that's going to be 5 and 2. 5 times 2 is 10, and 5 minus 2 is 3. But wait, we want a negative 3. So we want positive 2 minus 5. And now at this point, we're going to set these both equal to 0. X equals 5, and x equals negative 2. We have two different answers there. Okay? And then number 3, I'm not going to do that one. You can do that for practice if you like. It's going to work pretty much just like number 2.
Slight error here. I forgot when I put this in the packet that we cut this section out of this chapter, so we're just going to skip this.
Okay, so our next theorem, segments of chords theorem. If two chords intersect inside the circle, then the product of the lengths of one chord is equal to the product of the lengths of the other chord. Okay, so let's look at this. In this case, we have EA times EB is going to be the same as EC times ED. Okay? So red times green is going to equal red times green. And we'll play with that here. Okay, so it's kind of hard to see what's what, but this is supposed to be x plus 2. This is x plus 1. This is x. And this is x plus 4. So what that's saying is, this goes back to what we started off reviewing today, x times x plus 4 is going to be equal to x plus 2 times x plus 1. So, what we're going to do here is we're going to distribute and get x squared plus 4x. Yes, that looks like a 3, so let's clean that up. And here we're going to FOIL. So first, x squared. I'm going to do outer and inner together at the same time. 1x plus 2x, 3x, last, plus 2. Now the nice thing about this one is, My x squared are actually going to cancel out. When I subtract x squared, it's gone. Now I'm back to a linear equation. So I'm just going to subtract 3x and get x equals 2. Now that's not my answer. Notice it says find ML and JK. So ML is the entire length. Okay? So I need to plug in 2 here and 2 here. So ML is going to be 2 plus 2 is 4, 2 plus 1 is 3, that's going to be 7. And then JK, I'm going to plug in 2 here, which is just 2, plug in 2 here, 4 plus 2 is 6, plus 2 is 8. And that's it. Okay, tangent segment and secant segment. All right. So a tangent segment, remember, tangent just touches the outside, is a segment that is a tangent to a circle at an endpoint. So it's pretty much the tangent we've been talking about, just with endpoints. A secant segment is a segment that contains a chord of a circle and has exactly one endpoint outside the circle. The part of the secant segment is outside is called the external segment. So we don't call this the internal, we just call it the secant segment. It's the piece of the secant inside the circle. Alright, now an actual theorem based on this concept. Segments of secant theorem. If two secant segments share the same endpoint outside the circle, then the product of the lengths of the one secant segment and its external is equal to the product of the length of the other secant segment and its external. So in other words, we'll go with the red-green thing again here, EA, which is already red, times EB. Okay, so remember, let's look at it again. Because the product of the lengths of the one secant segment and its external secant segment, is equal to the product of the lengths of the other secant segment and its external segment. Sorry, I messed that up before. The secant segment is the entire part. I wasn't paying attention. So if you notice here, the entire thing is the secant segment, not just the part inside. And then the outside part is called the external. My mistake. So for red times green, we have the outside piece times the entire. And then EC in red times ED. Whoops, this should have been green. Keep with our color coding. Okay. So if it helps you to think about it, EA is the external times the entire thing. And EC is the external times the entire thing. So let's do a problem like that. And here's where we got to be careful. So if it helps, maybe remind yourself by doing this at the top. Exterior times entire. So the exterior is 9 times the entire, which is 11 plus 9, 20, equals the exterior of 10, and be careful here, x plus 10. So now we're going to multiply. 20 times 9 is 180, equals 10x plus 100. Remember, to distribute to both. Subtract 100, and you get 80. And then when you divide by 10, x is equal to 8. And we're done. It says just find the value of x. Okay, new theorem. Segments of secants and tangent theorem. If a secant segment and a tangent segment share an endpoint outside the circle, then the product of the lengths of the secant segment and its external, which we just did, equals the square of the length of the tangent. So similar to what we just did, EC times ED equals EA squared. So similar concept, okay? So in this case, the tangent, we're just going to square. And then we're going to do the same thing we just did. The outside times the entire segment. So x plus 8. So when I square 16, I'm going to get 256. That's supposed to be a big 6 to go with the big 2 and the big 5. Equals x squared plus 8x. Now I'm going to move the 256 over and get x squared plus 8x minus 256 equals 0. Now, I'm going to save some time. We could try factoring this and find two numbers that multiply to give me 256 is different by 8, but they don't exist. So this is not factorable. So we have to go back to the quadratic equation. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to plug that in, plug the numbers in. Remember, a is 1, b is 8, and c is negative 256. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times negative 256, which is c, all over 2 times 1. Okay? So that's going to be negative 8 plus or minus. Now when you crunch these numbers, okay, that's going to be 64 plus, okay, plus because negative 4 times negative 256 is a positive. That's going to be plus 1,024 all over 2. Now when you add 1,024 and 64, you get negative 8 plus or minus the square root of, that's going to be 1,088 over 2. What this simplifies to is negative 4 plus or minus 4 times the square root of 17. Okay? Which is not going to be a whole number, obviously, but we can just type it into our calculator, and we're not going to do the negative because we only want a positive value because we're doing measurements. So when we do that, x is going to be approximately 12.49. And that's what RS is, 12.49 or 12.5. I would accept either. Okay, last one. Find the radius of the aquarium tank. Okay, those are like salamanders swimming around in there. Okay, so what we have here is we have a tangent, 20 squared, equal to r plus 8. So that's going to be 2r plus 8 times the outside part. So that's going to be 400 equal to 16r plus 64. When I subtract 64, that's going to give me 336 equals 16r. And if I divide, I get 21. So the radius is 21. And that is it.